Okay, hello everyone. Uh, let's start. So, I welcome you all. Thank you for joining us today for this exciting session on PDF to BIM using Buildings AI. I'm Praveen, the Marketing Manager at Simulation Hub, and I'll be your host for this webinar. We are thrilled to have you with us. Today, we'll be discussing how Buildings AI is making the conventional process of converting PDF architectural drawings into building information models, which much more faster, easier, and more accurate using AI technologies. So, whether you're an architect, HVAC engineer, or energy consultant, this session will show you how this innovative technology can save your time, reduce errors, and significantly enhance your load calculation and energy simulation workflows. Swapnil next. Today we're thrilled to have Swapnil Dindorkar with us. Swapnil is an engineering simulation professional with over 14 years of experience in flow simulations for building physics and electronic thermal management. He currently leads the portfolio of simulation of products and solutions at CC Tech, focusing on whole building performance modeling. He has a background in mechanical engineering with professional certifications in areas like project management, digital business management, and design of net zero energy buildings. Joining us today is Aditya Ruikar, the product manager at CC Tech. Aditya plays a key role in developing and delivering high fidelity technologies across various industries, always with a focus on making them more accessible and user friendly. He'll be demonstrating the PDF to BIM workflows using some real world examples. Without further ado, let's start this session. I'll hand over to Swapnil. Swapnil, over to you.
Thank you, Praveen. Thank you for the introduction and thank you for getting this started. I'll just highlight what we are going to cover today in this webinar. For today, our focus is going to be the unique feature in Buildings AI software, which is PDF to BIM. Before we begin, just confirm whether my voice and everything is okay.
Yes,
Yeah,
Swapnil, it's
okay.
clear.
Thanks for the thumbs up. Today we'll cover these topics in this session. First, we'll start with understanding of basically why the need of this feature, and we'll focus on the broken starting point in the entire workflow of energy modeling, why 2D drawings basically slow down the energy modeling process. After that, we'll see what is the bottleneck in the current process of heat load calculations and energy modeling, which is basically starting with a 2D drawing and tracing over to prepare a 3D BIM out of it. Then we'll see our unique solution for this entire process, which is PDF to BIM solution or the PDF to BIM feature within Buildings AI, which is an automatic PDF to BIM converter or conversion process. After that, Aditya will show this entire transformation process in action using a demonstration. Then we'll also give you an overview of our findings of how this particular feature basically improves the traditional workflow and saves the time, gives better insights, and helps in faster modeling and smarter way to actually generate a 3D model out of 2D drawings of buildings. And we'll end with question and answer and discussion sessions after that. So going ahead now, first is basically we want to focus on the traditional workflow that is basically followed in order to come up with HVAC system sizing or HVAC calculations or building energy model, basically starting with any 2D floor plan. Now the starting point itself is broken because we feel that most of the architectural drawings are shared in 2D format. But for any type of building energy modeling or sustainability optimization, or even for advanced level of HVAC system sizing and analysis, a 3D model is required in order to assign all the metadata properties and to basically carry out the simulation. So there is a mismatch between the simulation needs and the starting point, which is 2D drawings in PDF format. And due to this, what happens is basically up to 60% of the time of the engineer working on this is spent on recreating the CAD geometry, which is present in 2D format. So basically, it's the information is already available, but it is in 2D format. and the engineer spends lots of time to basically recreate the entire floor plans of buildings to a 3D model, which could have been basically there could have been easier way to basically get this information into 3D. Now, due to this manual process, there is also a high risk of manual errors, and that continues. The error continues into simulation also. So it leads to simulation inaccuracies. There may be missing data in the PDF itself, which can lead to the dimension missing dimensions, missing documentation. All these things have to be manually checked, which can lead to delay. And this process, as it is the first point itself, hence we refer to it as the broken starting point, because this is the first point starting point of the entire further simulation process. We have spoken with early adopters of our software, and they have come up with many requirements. But I would like to highlight one of it is basically a comment that a lot of time is spent in reading and drawing a BIM model, cleaning the model, getting right analytics geometry for building load and energy simulation. And even if 50% of this initial time is saved in geometry creation, then such a software or a feature would be very much required, or it would help save a lot of efforts in the building energy modeling. Let us compare this process that is there right now, which is followed, and how this acts as a bottleneck in the energy modeling process. So what we refer to as manual traceover, which is basically getting the PDF file, overlaying it on top of some sort of sketcher, and then recreating the sketch so that the zones are captured, the walls are captured, and the glazing and everything is recaptured, and extruding or extracting the 3D information out of this. The traditional workflow focuses on energy modelers, beginning by importing PDF. Then they put a lot of efforts to draw every wall, window, door, zones, ensure that there is no gaps in the spaces that are created. All this is manually done. Each element requires manual inputs. Then, due to all these tedious manual steps involved, the process is never in hours. The process is always in days or even sometimes in weeks for large building structures. And because this is manual, the user with different level of practice, expertise, skills leads to the manual variability, which is also involved. And this can cause inconsistent quality across different building projects, or even the timelines across different teams can vary. There is no standardization or consistency in this process. So now, because of this, the geometry creation process itself has to be verified by some quality checker at the end, resolve conflicts, troubleshoot. Simulation also involves errors because of this process. And on top of this, the building energy modeling is never a single simulation or a single calculation process. The process has to be repeated till optimized design is obtained. And hence, any change in the design starts again from the beginning, which is basically your the 2D plan, and then the process repeats. So this is like a multiplying effect of manual TDS processes carried out across the entire project. So this is the real burden on the cost, on the human efforts, and also on the basically efficiency and consistency across different projects. We wanted to provide a simple solution for this entire process by using various automation and AI techniques. So what we have come up with as a feature in our Buildings AI software is an automatic PDF to BIM conversion process. It is an add-on feature, and basically it does what it simply does is convert your floor plans into direct 3D BIM models, which can be used ready to use for any type of building energy modeling setup or any type of HVAC system simulation setup. The user has to just upload the architectural PDF floor plans, and the AI automatically detects wall, windows, doors, zones, and spaces with precision. Then out of this, the floor plans are basically joined together across different floors, and a 3D model, which is a 3D BIM model ready for building energy simulation setup, is extruded out of the conversion feature. It can be used as is in our software, and it can be also exported to use basically to have compatibility with Energy Plus, Open Studio, and other simulation engines. In future, we are also working on extracting metadata, which means it can also automatically capture room area, building orientation, glazing ratios, material, thermal zone information from the PDF along with the geometrical information. Then currently it also can be exported as a separate Revit file, GBXML, IDF format to use in any of your customized simulation workflows. We estimate that the whole process can save up to 90% time in the geometry setup, and this same saved time can be later on put into much more complex analytics type of design optimization, energy analysis process, which leads to a much more efficient building energy modeling or HVAC system process. The steps involved in the feature are very simple. You start with a PDF model of floor plan, which is the starting step. There are only 3 steps involved. The tool basically converts this PDF model, or this PDF drawing into a detected boundary layout, which involves the tool or the feature also detecting the windows, the doors, and basically giving the user a feel of how this particular space or the 3D model will look like in the 2D format. So as you can see, the green are basically detected doors, windows, and the internal and external walls are also detected. So this is basically the layout which is detected. The internal spaces will be filled with zones and spaces, and it will be extruded into a 3D BIM model. There are some red detections also, which means the user has to manually basically insert a door or a window there to complete the close box BIM model. The second step is basically getting this entire layout into a FloorSpaceJS integrated sketcher or viewer in our Buildings AI software. So the open source FloorSpaceJS sketcher is integrated into our tool, and this entire layout fits into the FloorSpaceJS. The spaces are seen as detected, and the user has to just join across different floors and merge it into a single 3D BIM model. So the third step is basically the FloorSpaceJS imports into Buildings AI software a 3D BIM model, which is now ready to set up any type of energy simulations or simple HVAC system calculations. Load calculations can be easily performed on this once you have the BIM model. So it's just a 3-step process, and all these 3 steps will now be shown by Aditya in action in a short demo. Aditya, you can take over from here.
Thank you, Swapnil. Let me know if my screen is visible. Okay. So to access Buildings AI is a web application. You have to visit our website, simulationhub.com, and you have to have an account of Simulation Hub. Then click on this square box. Then you'll able to see our applications, where you have to click on Buildings AI dashboard. Once you clicked on that, you have to enter your login credentials. After login credentials, you will get landed over the Buildings AI dashboard, where you will able to see all the current projects created and past projects. Now I'll walk you through the PDF to BIM workflow. So as you can see, this demo video I'm sharing, you are onto the dashboard here, where you can see all the projects created by me. Click on the create project, provide your project information, select preferences, and the site location. So set in Houston. Then you will able to, on the left side, you will able to see all the tool sets of Buildings AI, using which you can model your building, your HVAC system, and in future we are also looking to integrate digital twin. Along with modeling, you can able to do various types of simulations like load, energy, and in future thermal comfort. Will be looking to integrate more and more simulation tools. So for this webinar, I am continuing with PDF to BIM. So you have to select on 2D floor plan. Then you can create a configuration of for PDF to BIM. Select your floor plan and from your device, provide a PDF or image of your floor plan. Yeah. Once imported, you can able to see all this PDF has been imported. Now, here what you have to do is first step is image refinement. Here you have to fine tune your image so that your walls should be clearly visible so that it will be helpful for AI to extract features from your floor plan. So basically you have to fine tune your contrast, details from you have to set how much details you want, level of details you want from your PDF. Once I've fine-tuned all these sliders, I have to click on apply refinement. Then you'll be able to see all the walls have been extracted. Now you have to this wall extraction slider, you have to move that so that all the walls from the PDF will get converted into green color. So all those walls have been selected and then click on extract wall to extract this one. Next step is as this buildings here don't know as of now what is scale of your floor plan. So you have to provide a scale. So it can be easily provided by the sketch tool. So you have to draw a line over your screen and enter the dimension for that line. Like 445 pixel is equal to 67.5. I know this dimension, so I'm entering that. And then for accurately creating building energy model, I have to also provide internal wall thickness. Then click on this run AI detection button. Here the AI magic starts. So we have trained this model so that it automatically identifies the symbols of doors and windows from your floor plan and detects it, as Swapnil showed you. It has identified all the windows and doors which are in green colors and red colors windows and doors. Those are also identified, but those are like it is not creating closed geometry for spaces. So those are highlighted in red color. So I have to delete those manually, and then we have given an option to manually also draw your doors and walls. So here adding manually these doors and walls. So this is like bigger curtain wall like window. Yeah. Once you provided all the you confirmed all the windows and doors, provide number of floors for which you wanted to copy this floor plan. So as of now, PDF to BIM is limited to only single floor plan. But in the upcoming couple of weeks, we are also coming up with different layouts of floor plan. So now the option is you provide number of floors you wanted to copy. Like this is a 6th floor building. And then export this floor plan. So this exported floor plan is exported into PDF to JSON, PDF to JS application, which is integrated inside buildings here, which is DOE developed and which is also along with OpenStudio, you get this. So most, I think people are familiar with this. So here you can confirm all those windows, doors, walls are correctly imported or not. You can also edit here. You can also change floor to floor height, floor to ceiling height, window height here. As I'm deleting here some of the doors, as from 2nd floor, those doors are not there in the PDF floor plan. And then confirm all those things. You can also name your spaces here. Yeah. Then next thing is building configuration. You have to next is go to building configuration. Here you import that FloorSpaceJS created using FloorSpaceJS application and create this. So in a few minutes, it will automatically convert that FloorSpaceJS into a Revit file. So now you can able to see that Revit file. So you can click on this windows and doors and walls of this created Revit file and change the envelope properties. For doing that, we have also provided option to segregate those with respect to different types of envelope components, directions, with respect to floors. You can segregate those envelope components and select, you can multi-select those and change those properties easily. The next stages are providing space types, doing zoning, and providing HVAC configuration. After HVAC configuration, you can able to see run load and energy simulation. So I'm directly jumping on the load and energy simulations so that you will get idea what kind of results Buildings AI can generate. So such kind of zone-wise, system-wise, and facilities-wise results it can generate for heating as well as cooling. I think this radio is fast. Then bifurcation of envelope components, you will be able to get this how much heat is coming through walls, fenestration, ceiling, roofs, from people, lights. For each zone, each system and facility, you could able to check that. You will also able to run annual energy simulation and get those results as well in the chart format as well as tabular format. Yeah. So see how effortlessly I can able to extract this building geometry from the PDF and run load and energy simulation. So now we have provided some, we have done testing of some of the bigger models with our application engineers. Swapnil will share findings from that. Over to you, Swapnil.
Yeah, thanks Aditya for that very insightful demonstration. And I hope people would have got an idea of how the entire energy modeling process becomes simpler and faster because of this feature. And if you have any further doubts, like you can always ask for a personalized demonstration where we can arrange a session, individual session meeting, and show for any custom floor plan also that you may have. So now coming back to, let us see what is the effect of such a feature, which can basically reduce your entire manual work of maybe a few hours or days into simple 3 steps of starting with 2D, converting into a layout which detects all the entities, and then directly converting into a 3D BIM model ready for the further simulations. So what we have observed through a series of testing of large building spaces, more than 500 zones approximately, is that the time to basically complete a optimization project basically reduces to 1/3 of what is with the traditional workflow. The traditional workflow, which is based on manually trace over process, that entire process is basically is reduced to just a few steps with automated detection of the entire layout. So majority of the savings are in the geometry preparation, but that also has a I would say a cascading effect into the further processes, which is savings on the setup, savings on design iterations because the repeat process is not required, and hence we have seen that it's almost like a 60% reduction in the entire project time, which is even the efforts as well as translates into cost savings. So it's a process which is made faster for modeling. It helps in getting better insights, And it's also basically a smarter way of doing the entire energy modeling process, because you're not spending time on recreating the same information manually. Overall, there is a 90% reduction in geometry setup, where the time of creation of 3D BIM reduces from days to hours. There is also consistency, because the whole process is not dependent on manual errors or manually recreating the 3D model. So for a particular geometry or a particular building layout, the repeatability or consistency is almost up to 90%. So for multiple design iterations, you are just consistently creating the same type of 3D model directly from 2D information. Also, if you are into optimization of the entire building model, the optimization scenarios are almost 10x faster. And hence, you could crunch the project time also to that scale to save cost and to come up with better insights, faster design. So the bottom line of this whole process, what we have tried by introducing this feature, is basically uh, reducing the manual steps involved, reducing the, I would say, uh, the recreating the same information, reducing that process, which translate into lower costs, faster building design turnaround, and also higher consistency or accuracy, because the process is repeatable in nature. So the same the feature works consistently across the same geometries, different geometries, and very little manual steps are involved in order to get the building information model for your energy modeling needs. That same time which we estimate is saved by this feature can be put into making better design decisions, optimizing the building layout faster or in a more insightful way, and also to extract much more performance data to save energy. So this is what we have tried by introducing this feature. It is also deployed across all the users that are currently using the software. Also, we are open to work with early adopters in making this feature more robust by handling their floor plans, which are in live projects or which are in archive projects. We are also open to offer this PDF to BIM on a feature as a product or as a software as a service, and help you to convert bulk of your PDF data on enterprise scale into Revit models or into models that you can directly use in your existing energy modeling workflows. So we are also open to a project-based implementation on an enterprise level of this feature. This can be customized to any of your requirements. If you have bulk project requirement, we can also deploy it as a customized version in your existing workflows. So feel free to reach us with any of your requirements with your existing PDF model layouts or your current project layouts, and we'll be glad to discuss the requirement and come up with solutions, customized solutions. So with this, I think this is all I got for this particular session, and we'll be open to question answers. Praveen will guide you through the rest of the session. Thank you.
Thanks, Swapnil and Aditya for the wonderful demonstration. Swapnil, you can reshare. Yeah. So, so that was really good. Demonst live, like to see the exact workflow, how AI has simplified the steps involved, manual steps, and time, how much time it saved. So, what's next? So you can log into you can visit simulationup.com, and you can either start your free trial right away, and we provide 15 days of trial, and we provide 5 GB of storage and simulation credits and things, so sufficient enough to explore the application and evaluate, do it in your project, sample projects. So if you feel, you can also schedule a call with Swapnil. You can click on request demo, and you can schedule a call with Swapnil. And for additional information and detailed interactions, so that will help. And for webinar attendees who schedules a call, the free trial will be extended to 2 months. So you request during the call, and we'll make sure we extend the trial period as well, and increased credits. so that can be accommodated. So that's the special offer for the webinar attendees and registered users. So thanks for joining the webinar. Now the session is open for questions. You can post your questions in the chat window or the Q&A box. Okay. So meanwhile, I'm collecting the questions. So meanwhile, I have a few. Let me post those questions to Swapnil uh, and Aditya, like who are can answer. So the demonstration showed the floor plan for multi floors, but it was the same floor plan for every floor. So what if we have a floor plan like multi floor with each floor has a different design or anything? Yeah, so that's the question we.
Just
Swapnil, you're
unmute
on
your.
mute.
Sorry about it. So yeah, so I'll take this one. There are two ways basically to do this. One is under development, and other is already available through the PDF to BIM feature itself. There is a you can extract the layout for each floor in that. Then there is a choice to manually merge these floor or name these as different floors. Then you extrude them into FloorSpaceJS, and there you give it as multiple floor layouts and join them together into 3D. This entire workflow is still under development. The other one that is right now available is export them as is, as different layouts, disconnected layouts in FloorSpaceJS, and then in FloorSpaceJS post-process them or modify them each floor manually so that it's the BIM 3D BIM model reflects that. So,
Okay, okay.
Aditya, you want to add anything to this?
No, I think you correctly told. So, yeah.
Okay, great.
Okay, the next question is how about the accuracy? Are there any gaps in the spaces or something? So how to deal with that? Will there be gaps in the spaces after the PDF to BIM floor plan detection?
Okay,
Yeah,
I'll go with this.
yeah.
So basically, you have to provide accurate internal wall thickness so that those gaps will get avoided. But still, if those gaps are there, arises, you are exporting that into FloorSpaceJS. You can go into FloorSpaceJS, edit those, fill those gaps, and then you can import that into built-in configuration to get error-free Revit file. So anyway, that's why we included this FloorSpaceJS stage so that you can anyway edit the input which generated through AI. So as you all know, it is 70% accurate. So you can edit anytime. And yeah, basically
So,
it reduces your time of the in comparison with traceover.
right. So, just a point to add to that is based on the floor plans that we have tested, and since this is a AI trained feature, we have observed around 70% success rate in terms of detection and also in terms of making a gap-free layout in FloorSpaceJS. Now that remaining 30% also depends on how regularly you use these feature on your existing project layouts, and gradually it will basically those gaps will also be reduced, and they will be consistently in the same places probably, so that you have a better manual way to just focus on those spaces and consistently remove them once they are uh, detected. So, I mean, that is
Okay,
another way,
yeah.
practical way.
Thanks. That answers the question. Yeah. So we got one more question from Mohammed Zahir. So thanks for the detailed presentation. And as you know, most of the consultant are working on Revit now, which means 3D layout is already ready. How this software will be helping in long run? So let me answer that, Mohammed Zahir. Like this, it's a welcome change. Most of the consultant are already using Revit. So that's a welcome change. This particular PDF to BIM is a AI feature in Buildings AI. Buildings AI already supports Revit import. So there, anyway, that workflow is well established and standard. That you can use that and model like do the load and energy calculation from Revit model directly. This is an additional feature just for the 2D drawings and things. So how they convert for those who use still has the challenge of manually converting the architectural drawings into BIM. So yes, very useful.
And Praveen, I think we could share the demo links for Revit import feature. So those are available on YouTube. Sure.
Sure. So another question from Ganesh. Does it identify thermal zones or help in zoning setup for energy simulation? Swapnil or Aditya would like to.
Yeah, I'll take this. So as of now, you can create thermal zones in FloorSpaceJS or in buildings or building configuration module. So currently it is not identify, it is only extracting geometry from it. And as Swapnil said, as a coming soon feature, we are targeting to read metadata like envelope schedules like Windows wall schedule, as well as if any other meta properties are there and those are relevant for building information modeling, those will be extracted and adjusted in the Revit file.
So in terms of the granular data from a PDF drawing floor plan, we took the first low-hanging basically information, which is the geometrical information. That is what we have automated right now. And each of those other entities also we will be integrating in the same feature as we progress, because other information like zones as well as material data, location data, I would say even it's present in the in the drawing file, but that needs some connectivity with the software that we are using, that is Buildings AI. So that will gradually come as a metadata import from the PDF.
Okay. So again, one more question from Mohammed Zaid. Thanks for bringing this question. Do you have energy analysis software? Yes. For those who directly, joined this particular webinar, they may not know what is like Buildings AI. We missed to add that. Thanks for bringing this. So Buildings AI, yes, it's a agentic AI platform for HVAC load calculation and energy analysis. So we do have that is the main output of energy. So as demonstrated by Aditya, you can see like the annual energy results and HVAC load reports. So those things are generated. So what we'll do is we'll share all the previous webinar links and demo links. So that will be helpful for. So thanks for bringing. We should have added one slide, at the start. So thanks for bringing that. Okay. Uh, okay. One more question is like other than PDF, what other formats do you support? Like, do you support image, PNG, for of drawings?
Yes, right now it's supported. We have observed in terms of resolution, there is some sort of criteria that is required, but because when you give the pixel scaling, that doesn't have like that. When you zoom in, that pixel shouldn't basically diffuse. I mean, but you can just create a image of, if you have image, a scan also should be possible to work in this feature.
Okay, great. So that's it for now. I guess there are no other questions. Yeah, there is one more. Can we import AutoCAD file directly? Okay. Uh, yes, we support
I
AutoCAD architecture models, DWG files from AutoCAD architecture module.
No, I think I just sorry to interrupt. I believe this is, you can even export a PDF of the same drawing from AutoCAD, and that can come into the same workflow. I mean, if I'm
Yeah.
not misunderstood in this
this
question.
question is like two things. One is like the regular workflow supports AutoCAD architectural files and things, and thanks Swapnil, that's I interpreted differently. So this is again the drawings from the AutoCAD can be like exported as PDF and again can be things. That's a second way to view it. Yeah. Okay. So for if you have any other questions, further questions, you can write to us, or like we'll share this recording and slide decks in the through your email IDs. And yes, we look forward to connect with you. You can request a demo or directly contact us, write to us. Thanks everyone for joining. Thanks Aditya and Swapnil for participating and presenting things. Thank you all.
Thank you all. I appreciate the time. Thank you for all the questions.
Thank you.